In our daily life, we come across many things which involve change in the state of matter. Can you list a few of it? Yes, there are many examples that we see around us, like the boiling of water, freezing of a liquid, sublimation of dry ice, etc. The most important thing that is involved in all these interconversions is thermal energy. So, what is the role of this energy in the interconversion of the state of matter? Thermal energy must move into or out of a substance to convert it from one state of matter to another. By taking into account the thermal energy changes in this video, we will see the interconversions of solid and liquid, liquid and gas, and solid and gas. Let us start with the interconversion between solids and liquids. When thermal energy flows into a solid, it is converted into liquid. This is called melting. When thermal energy is absorbed by a solid, its temperature rises until it reaches its melting point. The temperature at which a substance transforms from a solid to a liquid is known as its melting point. As the material melts at the melting point, thermal energy is continually added to it. The average kinetic energy of the particles does not change, since the temperature does not vary. Instead, the increased thermal energy just increases the particle's potential energy. When a liquid turns into a solid, it is called freezing. Thermal energy is evacuated from a substance when it cools. The temperature remains constant at the freezing point, while thermal energy continues to flow out of the substance. After the liquid has solidified into a solid, the temperature drops as the thermal energy is lost. Now, the next one is the interconversion between liquids and gases. We learn here the concepts of boiling and vaporization. Do you know what vaporization is? The transformation of a liquid into a gas is known as vaporization. When particles vaporize, the attraction forces between them become too weak to hold them close together. Particles disperse and travel on their own. Answer this one now. What is the opposite of vaporization called? It is termed condensation. Condensation is the transformation of a gas into a liquid. Thermal energy must be taken from gas for condensation to occur. The gas particles travel more slowly. As a result, the temperature of the gas drops and are transferred to liquid form. Now, if we see the term vaporization, it is often confused with terms like evaporation and boiling. These two are the phenomenon related to vaporization. So, what is boiling? The process of conversion of a liquid into its vapor form at its boiling point is called boiling. This is a phenomenon that occurs throughout the liquid, like that shown in this video. Suppose the pressure exerted by atmosphere is more. Then it becomes more difficult for the bubbles to develop. This indicates that, when the pressure on a liquid rises, the boiling point of the liquid rises as well. So, the boiling point also increases, with increase in the atmospheric pressure. Next is evaporation. Evaporation is a type of vaporization that occurs on the surface of a liquid as it changes into the vapor phase. For example, if we keep hot water in a cup, we can see vapors coming out of it, even when the temperature is not 373 Kelvin. Let us look at the interconversion between solids and gases. The process of direct conversion of solid to gas is termed sublimation. Sublimation is the transition of a material from a solid to a gaseous state, without converting it to a liquid state. This is an endothermic conversion. In this, the solid gains quite a high amount of thermal energy, which loosens the bond between the particles and the resultant is a direct conversion from the solid form into gaseous form. Then, what is the reverse process called? The reverse of it is called deposition. In this, the gas continuously loses thermal energy, but instead of converting into a liquid, it directly converts into a solid form as the loss of thermal energy is quite high. In this video, we learned about the interconversion of the state of matter, and also saw how thermal energy changes during the same.